Inheritance means acquiring the quality of the parent class to the child class. That is called as inheritance. So using the object of this last derived class, I can access the method salary and I can access also the method name. Multi-level inheritance is different and multiple inheritance is different. Keep in mind that, don't get confused, okay? Hello everyone, welcome to the session on Python programming for 4th semester B.Ca student. We are continuing the discussion on Unit 3. Myself Induje, Faculty of Computer Science Department, Vidhyaashram First Aid College, the Temple of Excellence, MYSURU. Let's continue the discussion on Unit 3, that is object-oriented concepts in Python programming language, right? So last session we have discussed classes, objects, and object as an argument, object as a parameter, object as a written value, right? So next, see one more very important concept of object-oriented programming, that is inheritance, right? What is inheritance? Inheritance means acquiring the quality of the parent class to the child class. That is called as inheritance. Let us see the formal definition, how we can define our inheritance. Inheritance can be defined as a process through which class acquires the features of our existing class without modification. That is called as inheritance. Is exactly same as, you can relate this inheritance exactly same with your genetic inheritance. You are inheriting some of the quality of your parents, some from your father, some from your mother, or some from your grandparents also. The same exactly we are implementing in programming concepts. Like class which inherits the features is referred to as a child class. Which inherits the features to itself is called as child class, and the class that which feature is inherited, from which the feature is inherited, is called what? Parent class. Hope all of you clear what is child class and what is parent class. In other words, we can newly form the class is in a child class, while the existing class is known as a parent class. That newly formed class is what? Child class, and already existing is called as parent class. In programming terms, we say that the child class acquires all the attributes and then the method. What we are inheriting? We are inheriting the attributes and the method of a parent class without any modification to the child class, and child class can also hold its own attributes and the methods. So this is introduction about the inheritance. Let us see the syntax, how we are implementing this concept in Python programming language. What is the syntax for inheritance? First, we should have one parent class, right? So this is a class. You know the how the syntax is for defining the parent, defining the class name, class keyword with the name of the class. So we have to create two classes. One is a parent class and one is a child class. In the parent class, in the body of the parent class, what will be having? We'll be having its attribute and methods. So parent class has its own attributes and the child class has its own attributes and methods, with the attributes and method which are inherited by the parent class. This is a syntax for creating the inheritance. Then how many different types of inheritance are there? So these are different types of inheritance. We define 6 different types of inheritance. One is single inheritance, where the simple procedure follows a child class inheriting the properties of the parent class. That is a single inheritance. Multi-level inheritance. We have multi-level inheritance. It's exactly same as that you are inheriting some of the properties or some of the features of your grandparents. Like it will be in the multi-level. Minimum level what we have in the multi-level is 3 level of inheritance should be there. Then hierarchical inheritance where we have a different level, a single parent with the different children, number of children. That is hierarchical. And multiple means two base class deriving one child class. That is multiple inheritance. Hybrid, combination of these two can be in a hybrid, and multipath is combination of any of these above is called as multipath inheritance. Let us see each type of inheritance in detail with their syntax and the example for each. How to create the class? First, how to create the parent class. You know how to create the class with the keyword class, and then the class name. We have to create the class with the body of the class, whatever we have to define the functions or the attributes of the class. See how to create the parent class. It's same as that of class keyword, name of the class, and then if object we are passing any objects, right? So in this we are using the constructor. We have already discussed the constructor in the previous session. Why constructor used? It is execute itself when the object is created, right? So defining the init function with the two parameters, name and id. We are calling the same parameter with the help of the self argument. Then what we have to do? We have one function. This is what name and id are the attributes, and display is a method of what? Of parent class, right? Of parent class. Now what we are deriving the code means we are creating an object that belongs to the class person by passing the parameter. Name is what? Satyam, and what is ID? 102 is the ID. So we are calling the display function, which is also a member of that particular class. So after that, what it will be display? Once we call the display function, it will display the name and it will display the ID. Name and ID. This is how we created the parent class. Is similar to that of as we are creating a normal class. So coming into the child class, how we have to create the child class? In the child class, we have to use a keyword class, then the class name, and this is what? The name of parent class. Name of what? Parent class within the braces. This is how we are going to create the child class. Class keyword, class name, that is a child class name, and within the parenthesis what we have to give? We have to give the parent class name. By this parent class person, we are inheriting the attribute in the method of this parent class. What are the attribute and the method of parent class? Name, ID, these are all attributes, and display is a method, right? So we are inheriting the name, ID and the display to the child class employee. EMP stands for employee here. Okay, apart from these attributes and then the function method, it will have its own attributes and then the methods. So here we have defined one function called print, which is a self-defined, or it's a own method of the child class. It's a own method of child class. So what we are doing in that? We are printing, or we are saying that employee is a child class, or class employee has been called. So after that, what we have to do? We have to create the object. What we are doing here? We are creating the object of which class? Of child class. Right? We are creating the object of the child class. What is the name of the object? Employee underscore detail is the name of the object that belongs to which class? That belongs to child class employee. So as child class inherits the properties name and then the ID of the parent class, we can give that as directly as an argument, because we are using a init function there, right? So this is what? Name, and this is ID. You are inheriting the directly attributes of parent class name and ID. Then after that, what we are doing? After creating the object, with the help of the object, I am calling the display function, which is a parent method, which is a parent method. We are calling parent, which is not defined in the class employee, right? And we can also use the function which is defined within the child class employee. So what would be the output of this? Employee detail. We are creating employee. When it calls the display function, it calls the display function of whose? Parents display function. There what we are printing? We are printing the name and the ID. So Mayank and 103 will be printed. Soon after that, we are calling one more function, that is a print function, which is a own method of the child class. What we have in that? Employee class called. So employee class is called. This will be printed as an output. Hope all of you clear how to create a parent class, how to create the child class, as well as how to access the attributes and then the method of a parent class to the child class using the object created by the child class. So next what we have is single level inheritance. Single level inheritance is one of the simplest and easiest type of inheritance. Just we have a parent, from parent the attributes and the methods are inherited to the child. That is a single level inheritance. We have only one level, parent and then the child, that's all. In a single level inheritance, the child class inherit all the attributes and the methods of the parent class, right? This enables the reusability and modularity. Why we are doing this? To enable the reusability. We need not to define the same attributes in the same function in the child class again. We can, once defined in the parent class, can be used to the child class directly. So that is a reusability and modularity. In this case, class A is a parent class and the class B is a child class. Class B has its own unique attributes in the method, even it inherits the attributes methods of the class A. Right. So what? Even it inherits the attributes and then the methods of the parent class, it can have its own methods and then the attribute also. The syntax of creating the single inheritance, how we are doing? Class, parent class is what? The class name. Then what all the attributes and the method of the parent class. Then child class, create a child class with a child class name. So here what we have? We have to have a class keyword, class, child class, then parent, from which we are inheriting. From the parent class we are inheriting. So we have to represent that within the braces. Then child class attribute has to be mentioned, if any there. Okay. Then example for single inheritance, we have one class called animal, which is in a base class or the parent class. Parent class is also called as a base class. Okay, base class. For this particular base class, we have a attribute. What is attribute? Name is an attribute. And what is a method? Eat is a method. What is a function of animal? Animal function, one of the animal's function is to eat, sleep, walk, like this. So we are defining one of the major function of the animal, that is eat, as a method to the class animal. So in that what we are printing? I can eat, that animal can eat. After the base class, what we are creating? We are creating one child class, derived class. Child class is also called as derived class, right? Derived class. What is the name of the class? Dog is the name of the class, which is derived from where? From the base class animal. Class name is, derived class name is dog. From where it is derived? It is derived from the base class animal. Okay, now it has its own function or the method called display. What it is displaying? My name is. It is displaying my name is so and so. And we are calling what? We are calling the name, which is an attribute. We are calling an attribute of parent class. Right, which we have declared here in the parent class. So Let us see creating an object here. We have created one object. That object belongs to which class? To the child class. What is the name of the child class? That is dog. Right. Object Labrador is equal to dog. We are creating the object of the class dog. And Labrador dot name. Name is an attribute of parent class. So what I'm giving? I'm giving the value as Rohu. What is the name of the dog? Rohu. And it is what? It is again a method from the parent class. So it will call from the parent class again. So I can eat is a thing what we have written in the each function or the method, and display. So display my name is what? Rohu. We are accessing it from parent class to the child class. This is what the example for single inheritance. So that's how we can represent it in diagrammatic form. What are the attribute? This is a method. This is a method. We have a two methods and one attribute. These two methods are inherited from the, that is a base class, that is animal, and this single will be other function or the method of the child class. Next, multi-level inheritance. What do you mean by multi-level inheritance? As already told you, it will have a different level of inheritance, like inheriting the quality of your grandparent from the grandparent to your parent, from the parent to the child. That is a multi-level inheritance. Multi-level inheritance is a type of inheritance where the class is created from the derived class. When we have a base class, right? From base class we are getting what? Derived class. From derived class again we are getting a child class. Right? This is a multi-level inheritance. Creating a method or creating derived classes from its inherited base class. Multi-level inheritance shows the possibility of inheriting from the derived class or from the child class. We are inheriting from the derived class to one more derived class. So minimal level of inheritance is tier 3 structure. So minimum level, what we have? Base, derived 1 and derived 2. 3 level of inheritance we should have. Which child class has inherited the future from the derived class, which in turn inherit the properties from the super class. So here what we call this base class, we call it as super class. Okay, we call it as super class. The derived class can access and extend the attributes in the method defined by both parent class. This child class can access this attributes in the method and also the superclass attributes in the methods. That is about the multi-level inheritance. So how the syntax of multi-level inheritance? We have to create a class that is a base class. From the base class, we have to have its own attributes and in the method. Then the derived class. Derived class is what? So derived class is here parent. That is a derived one class. Where we are derived from? From the base class. That is a grandparent class. Then child. Child is derived from where? From the parent class. So like this. It is derived from the base class. Derived one class is derived from the derived 2 class. So clear, it will have its own attribute, it may have its own attribute and in the methods. So let us see the example of multi-level inheritance. In the multi-level inheritance, we have a base class as an employee. Employee is working for the salary. Salary is a one more derived class and he is working with a particular designation. So this is a first level, this is a second level and this is a third level of inheritance. Minimum level of inheritance what we have is 3 level of inheritance. So in the first level, what is the base class? That is the employee. It has its own function or the method called name. Name of the employee is something, and then he is working for what? He is working for the salary. So salary is derived from the base class employee. So after that we have one particular function or the method. This is a method of child 1, child class or derived class. Right? So this is a method. From this salary, he is working for that particular designation in the company. So this is also called derived 2. derived to class. Here also we have one method, that is a designation. When we call the object, call is what? Call is a object of which class? Of the last class, last derived class, that is a designation. So using the object of this last derived class, I can access the method salary and I can access also the method name. So call dot name, what it will give? It will give Kush, right? Then call dot salary, what it will give? It will give a result as 10,000. Call dot designation is working as what? Is working as a test engineer. This would be the output for when we call these methods of the previous classes, base classes and the derived one classes. We are going to get the output as Kushal 10,000 and test engineer. So let us see the pictorial representation, how we are going to represent multi-level inheritance. So as I told you, class A, class B inherited by class A and class C is inherited by class B. Base class, derived class from the base class, derived class from the derived class. Okay, this is a derived class from the base class and this is a derived class from the derived class. This is how we are going to represent the multiple inheritance in diagrammatic form. Next type of inheritance what we have is multiple inheritance. Multi-level inheritance is different and multiple inheritance is different. Keep in mind that, don't get confused, okay. So in the multiple inheritance what we are doing, where derived class inherits the property and behavior of multiple base class. How? We are deriving base class 1 and base class 2. The properties will be derived to the derived class 1. Both the properties of B1 and B2 will be derived to the derived class 1 or the child class 1. In this type of inheritance, a class can inherit the attribute or the methods from more than one parent class. More than one parent class. In this, the child class inherits both the parent class 1 and parent class 2 using the multiple inheritance. The class can access and extend the attributes in the method defined by both the parent class. It can access and it can extend the method to its own. So syntax of multiple inheritance, what we have? We have a base class 1, we have a base class 2. Here, when we are defining the child class, we have to inherit base class 1 property and also we have to inherit base class 2 property. So we have to be separated to how many number of parents are there. Each parents will be separated by comma and it has to be represented within the braces. This is a syntax of creating the multiple inheritance. Base class 1 with its own attributes in the method, base class 2 with its own attributes in the method, and child class accessing base class 1 and the base class 2 also with its own attributes and then the methods. So here you have to make a note that this base class 2 is not derived from the base class 1. So base class 2 cannot access attributes and methods of base class 1. Okay, this base class 2 cannot access the methods and then the attributes of base class 1 because it is not inherited. These are all two separate classes. So, but child class can access base class 2 as well as base class 1 attributes and then method. Example, we have an employee class, we have a salary and a designation. These two are the base class 1 and base class 2. These are all not inherited classes. You can see the syntax. These are all not inherited classes. So when it comes to this designation, employee is and salary. These designation is inherited by employee and then the salary, both the classes. So as the output will be same, it can access the name, it can access the salary and it can access the designation of the particular person or particular employee by using the object of last derived class, object of the derived class. Okay. Next, how do we gonna represent this in the form of diagram? Parent class 1, parent class 2, or you can have n number of parent class. This child class can access all the attributes of any of the parent class. So then hierarchical inheritance, as name itself indicate, we have a hierarchy, we have a levels in the inheritance, that is called as hierarchical inheritance, where we have a single parent and we have a different childs. That is a parent class, child 1, child 2, so on up to child n. Number of children for the single parents is more than 1. Then it is called as hierarchical inheritance. Hierarchical, where the multiple derived classes inherit the property of the single base classes. Multiple derived classes inheriting the properties of the single base class. Here the base class serves as a common parent for the multiple derived class. For C1, C2 up to Cn, which is a parent, only P is a parent. That is a common parent for all the derived classes. Which can have our own additional attributes and then the method. This child class can have its own additional attribute, different attributes and then the method. But this C1 cannot access the C2, C2 cannot access the C3, but it can access the P. Okay. Hierarchical inheritance allows for creating the hierarchical structure of the classes, where the different derived classes can have their own specified features while separating common characters defined as a base class. We have a common characters for all these child classes which is derived from the parent class, though it will be different from each other. Hierarchical inheritance, the derived classes can access and extend the functionality base of the base class, not with the siblings or the child class. They can add their own unique attributes and then the method while still utilizing the common features defined in the base class. The syntax for hierarchical inheritance: base class, derived class 1 inheriting the property of the base class, derived class 2 inheriting the properties of the base class itself. That is how we are going to define our hierarchical inheritance. So when we are defining the base class, it should have its own attributes, and then the method, when you are deriving the derived class 1 from the base class, it will have all the attributes and the method of the base class 1, as well as it will have its own methods and the attribute. Similarly, derived class 2 will also have the attributes and the methods of the base class and its own attributes and method. In both the derived class 1 and 2, inheritance from the base class demonstrate the hierarchical inheritance. The derived class can access and extend the attributes and the method defined in the base class. So let us see the example for hierarchical inheritance. In the hierarchical inheritance, what we have taken as a base class is animal, right? Animal, it can be herbivorous, carnivorous, wild animal, domestic animal, like that we have different categories. So let us see what animal base class is deriving. Okay, in animal base class, what is a attribute we have? Name, and the sound is a function what we have. Then animal class is deriving one subclass or the child class, that is dog, and also it is deriving one more child class, that is cat. Both are animal, right? So both inherits the basic property of animal. What is the basic property of animal? Animal should have a name and animal should have some sound to itself, right? So when we are defining the child class 1, we are inheriting the properties of the animal. What is a property? Name. And what is a method? Sound. So we are inheriting both. Apart from this, it has its own sound, because dog has its own sound and cat has its own sound. What we are doing here? We are passing this function. We are not executing this particular method. This particular method will be executed with respect to the dog class and with respect to the cat class. So what it returns? It returns a self. What is a name? Name, it is the name of the dog, says Oof, and name of the cat. Name of the cat says what? Cat says meow, right? So that's how we are going to. So for creating this, to accessing this, we have to create the object of the dog separately and we have to create the object of the cat separately. See here, dog is an object that belongs to the class dog and cat is an object that belongs to the class cat. Using this dog and then the cat, what we have to do? We have to print the methods or the attributes. So print dog dot sound. What it will print? It will print that self dot name. What is the self dot name we have given here? Self dot name is Buddy, right? Buddy says off, right? That is going to be displayed as your output. When we call same sound function with respect to the cat object, then what it will show? What is the name we have given for the cat? That is Whiskers. Whiskers sounds as says meow, right? So that would be the output. Buddy says off and Whiskers says meow. So next, hierarchical inheritance, how we are going to represent animal. What we have is different types of derived classes. Cat, dog, lion, you can have different type of derived classes here. So then hybrid inheritance in the Python. In a hybrid means it's a combination of multiple inheritance, such as a multiple inheritance and multi-level inheritance. Multiple inheritance and multi-level inheritance combining, as hybrid itself says, it's a combination of two different things, right? So what we are combining? We are combining the multiple and multi-level inheritance in the hybrid inheritance. It allows a class to inherit the properties and behavior of the multiple base classes as well as the classes of multi-level inheritance. Like example, what we see, or the syntax for the hybrid inheritance is base class 1, base class 2, right? Multiple inheritance, base class 2 attributes and then the methods. So intermediate class inheriting the base class 1 property and the class derived will be inherited by the intermediate class and then the base class 2. In that case, intermediate class is derived by base class 1 and the base, so the properties of the base class 1 is given to the derived class itself. Okay, what we are doing? We are creating a two base classes, base class 1 and base class 2. Base class, intermediate class means middle class will be derived from the base class 1. So next what we are creating? We are creating the derived class, where derived class is derived from which classes? It is derived from the intermediate class as well as from the base class 2. Right, that intermediate class and base class. Indirectly, this intermediate class is inheriting the properties of the base class. Thus, the derived class indirectly inheriting the properties of the base class 1. So, this is a hybrid inheritance. That is a parent class, class 1 child and class 2 child. Like class 3, it is inheriting indirectly from the base class. This is hybrid class. Then one more type of inheritance is multipath inheritance. Multipath inheritance refers to the situation in the object-oriented programming where the class from the multiple base classes and there exist a common ancestors to the class. We have a common ancestor for the multiple classes or multiple base classes. The typical inheritance hierarchy, a derived class can inherit from the single base class. So how we are going to do that? We have one base class, we have two derived class, and here we have applying what? Hierarchical inheritance. It is a combination of what? Combination of multiple inheritance and hierarchical inheritance. Multipath inheritance can offer the flexibility and code reusability in certain scenarios, but it can also make the code more complex. What is the disadvantage what we have in the multipath is it will make more complex. You should be having the clear idea what you are inheriting from where and which type of inheritance you are using. Multipath inheritance, you are using multiple inheritance as well as a hybrid inheritance. In this example, the class D inherits from the both class B and then the class C. D is inherited from B and C, which means that indirectly it is inheriting the property of what? Property of A. So this is a diagrammatic representation of multipath inheritance. So let us see the example as same example, class A, class B. Class B is derived from the class A and class C is derived from also the class A. Both B and C is derived from the class A, but D is derived from B and C. B and C. Class D is derived from class B and class C. That's how we are going to represent the multipath inheritance. So what are the advantage of inheritance and the disadvantage of inheritance? Why we have to use inheritance? First and the foremost things we know why we have to use inheritance for the code reusability. We need not to define all the attributes in the method again and again when each child class is created. So let us see the advantage what we have by using the inheritance, that is a modular code base, that is increase the modularity. Breaking down the code base into the modules makes a easier understanding. Okay, in spite of giving all thing in a single, we are dividing that in the form of classes that will make us to understand easy which particular method or the attributes belongs to which class and how we have to access those attributes. Then code reusability, as just I told you, we use inheritance when we have to use a code reusability. The child class copies all the attributes in the method of the parent class into its class and uses it, saves the time of coding efforts by rewriting them, thus following a modularity program. And then less development and maintenance cost. As we have developed, we have created the attributes and method, or we have created the class as a blueprint and kept it, it requires a less time. It requires a less development time and derived classes will automatically follow the same. What maintenance cost will be also less. Reusability, inheritance allows obtaining the new classes from the existing class. New classes from the existing class. We are not creating number of new classes from the existing classes without modification. This helps with the reusability, reusing the information what is provided. So these are all the advantage of inheritance. Let's see what is the disadvantage of inheritance. In the disadvantage of inheritance, decrease in the execution speed. As we have a different level of inheritance, when we are inheriting attributes and in the methods of the parent class, it will definitely take comparatively larger time to inherit the properties and then the methods, attributes and then the methods. Loading a multiple classes because they are interdependent. Why it will take a larger time? Because interdependent. The answer will be interdependent. The tightly coupled classes, that is one more disadvantage. Even though the parent class can be executed independently, the child class can only be conducted by defining the parent class. We have to create the object of the parent class to execute the functions or the methods of the parent class. This is a major disadvantage what we have in the inheritance. So that's all about the inheritance in Python programming language. Thank you.